Today I will continue the discussion of signals and systems. In last session I have explained you about the basic signals. Let us continue the session. This is the uh, fourth standard signal, which is called a unit ramp signal. Unit unit ramp ramp signal. Unit ramp signal. Okay. This is called a unit ramp signal. This is represented by R of t. This is represented by R of t, and this definition is t t for t greater than equal to 0 means its slope is t for t greater than equal to 0 and 0 for t less than 0. Okay. How do you represent this signal? Let us consider this as a time t axis, and this is the amplitude axis. As you all know, I have told in the last video, amplitude axis. How do you write this? Just draw signal, straight line, that is straight line which has a slope 1. slope 1 Slope 1 means if you write this as t here I have not written something. This is what this is I have not written anything means here as you all know, and anything is no, nothing is there means here one is there means one is multiplied means this slope of this signal is 1. Okay. Next signal is basically next signal next standard signal is the triangular signal. um, there is not so much difference in let us draw a triangular signal. This is what fifth basic signal. The basic signal, triangular triangular signal triangular signal. Okay. Triangular signal, this is how it is. This is the diagrammatic representation of a triangular signal. Means this will start from -1, and this the bandwidth means the signal width may be anything. It can be 2 or 3. It is represented as tri of t. And as you all know, here I have written this minus 1 to +1 means here -1 to 0 means 1, width is 1, and 0 to 1 is 1 means width. How much is its width? Width is 2, is equal to 2. Okay. This is about the triangular signal. And next is the basic very important signal which is basically used in signals. That is the signum function. Signum function, or function, or signal you can say. Okay. Signum function. Okay. Signum function. Okay. Signum function. How will you draw this? This is basically formed by uh, unit step function only. By doing some operation on unit step function, you can get a signum function. It is represented as, it is means it is indicated as a signum, sgn. This is represented, this is sgn of t. Okay. How do you draw? Let us draw. This is how I will tell you. This is how, means it is from -infinity to 0. It is its amplitude is minus 1, minus 1, minus 1. And from 0 to 0 to from 0 to from 0 to plus infinity, its amplitude is plus 1. Okay, plus 1. But there is nothing here in at 0. There is no amplitude or nothing is there. This is basically called signum function. Okay, signum. Okay, next the last yeah. Okay, next signal is the exponential signal. As you all know, there are two types: exponentially increasing or exponentially decreasing. uh, its general form is that is first exponential signal. This is how much number? I think it is 7 or 8, I don't know. That is 7 or 8. Okay, exponential signal, exponential, exp, exponential signal, exponential signal. I'm writing in shortcut. Okay. Exponential signal, how it is represented? Exponential signal is represented as exponential e power sigma t or at, whatever. This sigma represent what is the what is it, it represents it is decreasing exponential or increasing exponential. If sigma is equal to minus a, something, consider some a, minus a means it is exponentially decreasing, exponentially decreasing. Okay, exponentially decreasing. If the signal, if sigma, this is sigma is plus a, means plus a means the exponentially increasing signal, like this. Okay, these are the basic signals which you have to know before understanding the signals and systems. Okay, some more signals are also there, but signal these signals are familiar to, means the sine signal, cosine signal. Okay, okay, next next what I will tell you is how the what the I have told you about the unit step function, but how do you represent unit step sequence? Sequence means the discrete time configuration of the unit step function. As I have already told you that how to convert this continuous time signal into discrete time signal, means I will revise you once more. Means what you will do, you will take a signal, you will take some signal. Let us consider u of t, that is unit step function. As you have already, that is u of t, that is unit step function, amplitude 1, and this is the time axis. Okay, if you pass this signal through a switch switch if you pass this signal through a switch, then what you will get, means a time for a constant interval of time. If you open and close this switch, you will get this same signal, but what, in some gap, means some intervals of gap, means what you will get, this one, this is only, means it is not now, it you will not represented, you will not represent this this as t, you will represent it as n, because it is constant for a constant interval of time. It is showing, means discrete means for 1 2 3, not for continuous values. Okay, that is you will write here also u of n, it is a function of n, no, that's why. Okay, here amplitude is 1 for all, no, for 0 it is 1, for 1 it is 1, for 2 it is 1, for 3 it is 1, means 0 1 2 3. Okay, for continuous means it is up to infinity, it is constant. That is how do you convert a continuous signal into discrete time signal, and how will you represent this? This is called unit step sequence or unit step discrete signal. Okay, another way, how can you make this signal also, means how do you generate the unit step function, means as you all know, I have told you in last video, that is, as you all know, the that is that is this delta function, or delta, or what you will say, impulse function, delta function, or unit impulse function. How will you represent that? Is it is zero, it at zero it is a constant one. How you have represented delta of t is equal to what, 1 for t is equal to 0, and for other than t is equal to 0, it is 0, no, 0. Okay, t not equal to 0, it is 0, its amplitude is 0, means how do you convert this into unit step sequence? What you will do, just what you will do is just draw another signal. Okay, just what you will do is shift it, this signal, it is at 0, no, if you shift it to at 1, and then its amplitude will remain constant only. If you will shift, and then you add these both signal, what you will get, like this, no, like this, two 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 lines. That is, if you add some more signal, some similarly, shift it and add it, then you will get what, unit step function. That is how you will get unit step sequence. Okay, unit step sequence, u of n, this is the u of n, this is the u of n. Okay, okay, next what will next okay, next, transformation of the signals. How signals are transformed? There are basically, for transformation of signals, you will use, basically, transformation of signals, you will use four basic operations, that is time scaling, time shifting, time reversal, and amplitude scaling. Very important topic for every for any competitive exam you will get. This is a very important concept. Let us start this. First is time scaling. I will deal you this topic with very good examples. Then you will get to know what is its move. Okay, two three for one operation. I will use two 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 examples. Okay, time scaling. Okay, time scaling. First is the time scaling. First I will write the heading. Okay, transformation of signals. Transformation of formation transformation of signals. Transformation means what? Changing it somehow, changing its properties, or something, value, or something, that is called the transformation. Okay, first transformation is time scaling. Time scaling. Okay, time scaling. How? I will explain you with example. Let us consider a rectangular signal. You will don't let us just take it as x of t. Anyhow you can represent it by anyhow. Okay. Let us consider this as -1, and this is time axis, no, time axis, and this is amplitude axis. Here, for time scaling operation, don't bother about this what, amplitude, just focus on the times. time axis. What you will do, this x of t signal is there, no? If you what okay, what you will do is just if you write this signal, you represent this signal x of t, x of 3t. 3t means what you are doing is you are making the time means if you are writing this inside 3 means you are dividing it by 3. Dividing this signal by 3 means you are making this signal chota, small, means width is becoming small, minus 1 by 3 and my 1 by 3. What uh, don't confuse here. If you write inside multiply 3 means you should divide it in graph by 3 means you are making the width small. Yeah. Okay. In contrast, if you write x of t, x of t divided by 5, divided by 5 means what you are doing, you are expanding the signal. uh, Earlier I have written 1, no, width was what the width was 1 1. Let us consider minus 1 and plus 1. If you write here 5, you should multiply by 5 here, means 5 means what, the signal will happen, signal will expand. Okay, expand like this. Don't consider, I have already said you that don't consider about the amplitude. What you have write, minus 5 to plus 5. That's all. That's about the time scaling. Okay, this is very important transformation. The next second let us go to second topic, that is second operation or transformation, time shifting. Time time shifting. Time shifting time shifting time shifting For time shifting, let us consider some signal means I will take a triangular signal and its width is let us consider this as 3 minus 3 and this is plus 3. This is let us consider this as this signal as what, some y of t, and this is time axis, as you all know. uh, what for time shifting, what, as the name indicates, time shifting means you are shifting the signal by time. Means if you represent y of t, y of t minus 3, minus 3 means what, as minus means you have to shift it by right, plus means you have to shift it by left. Okay, don't get confused. Plus means left shift, minus means right shift. Okay, minus means right shift, plus means left shift. Okay, now I have written minus 3. Minus 3 means what you have to do, you should shift this signal left side. What, sorry, right side. Minus means right side. Okay, how do you write? Simply this signal. Okay, what, just what you will do is minus is there, no, if you add plus 3 here, plus 3 here, plus 3, what, the signal, what, here minus 3 mean, here minus means you should shift it by right, and you should for operating on signal you should add that by plus, means minus 3 plus 3 means 0. The signal will start from 0 and end at 6. This is what the time shifting means. You are shifting the signal. This was the earlier signal. Next, after shifting, the signal is shifted to from minus 0 to 6. The width has not changed. That is, the width was same only, but the signal is only shifted. This is about your time shifting operation. Next, the third one. Third is what? Time reversal. Time reversal. Time reversal means what? Let us now consider some signal. I will draw a beautiful signal. Let us see this signal. Time reversal. Okay, this signal. Let us consider this signal. Let us consider this. No, don't bother about amplitude 2. These are one something. And this consider this as t. Okay, okay. This has 1. This has 0. This has 2. This has 3. Okay, this is one basic signal. Let us represent it, give some notation, just as z of t, okay, z of t, okay, z of t, okay. What you will do in time reversal? Nothing. Basic operation. It is a very basic operation. Time reversal, just you have to represent the signal as z of t is equal to, inside the bracket you have, if you write minus t, this is the time reversed signal of the z of t. How do you draw? Nothing. What? Mirror image of this. Mirror image. If you keep this signal in mirror, you will get the opposite face. That is how you will draw. How you will draw like this, okay, like this, okay. Same signal. It is just write in minus sign. You write -1, -2. This has -2, and this has what, -3. And amplitude remains constant. Don't bother about the amplitude here. Okay, this is about the time reversal operation. This is very important operation. How do you represent? Means inside the bracket, if you write minus, means you have to reverse the signal. You have to reverse means mirror. If you keep the signal in mirror image, how will it look? That is what the time reversal operation. Last, the fourth operation and the last very important operation, that is the amplitude scaling. Scaling amplitude scaling. Okay, amplitude scaling means amplitude scaling. Let us, for amplitude scaling, let us consider some signal what some signal. Okay, let's take this signal, okay, for amplitude shifting. Okay, here you have to consider the amplitude. If the amplitude is, let us consider the amplitude of the signal is +2. That is x of t. Consider x of t signal. This is the t time axis. Okay, this is the time t axis. What we will do for for amplitude shifting? For amplitude shifting, you should not go into the what bracket side of the signal representation. Means just you have to write x of t. You don't go inside this bracket. For amplitude shifting, outside the bracket means, if you write this, it has three means amplitude shifting. Amplitude scaling means multiplying this signal by 3, means it is increasing its height. That's it. Amplitude scaling means increasing the height. Okay, time scaling means increasing the width or decreasing the width. Amplitude scaling means decreasing the height or increasing the height. And now if I write it as 3 means you should increase the height. Means the height is 2 here. If you if you multiply it with 3, the what height, what multiplied by 3, what it will become? What? 2 3s are 6, no? 6 means what? That is, that is 6. Okay, that is 6. This is what about the transformation of the signal. Okay. um, Thank you for watching this video, and like and share. Okay, thank you very much. Assalamu alaikum. Good night.